So, look at the rainbow right there. Okay, using the figure below, I know that PQ is congruent to PR, and I know TQ is congruent to TR. Okay, go ahead and press pause and see if you can try these reasons. Okay, it kind of goes back to module 1, so substitution property comes back, maybe transitive property, maybe angle addition property, those kind of come back. Okay, so see if you can try these on your own, and then we'll go over them. So press pause and give it a shot. All right, before we go over the answer, I'm going to read this connection to history real quick because I think it's so interesting, and it basically says this was a really hard proof, okay? So connection to history, Euclid's proof of the isosceles triangle theorem, which we're about to do, is given as the 5th proposition in Euclid's book of the elements. Is somewhat subtle and has been given the nickname Pons Asinorum, Latin for bridges of asses. Okay, the two reasons why this proposition earned its name are: 1, Euclid's diagram for this theorem looks like a bridge. Okay, this kind of looks like a drawbridge, going up and going down. Okay, 2nd, this was the first proposition that tested students' ability to understand more advanced concepts in Euclidean geometry. Okay, so this proof was to test students' ability to understand advanced mathematics. Okay, therefore, this proposition served as a bridge from the trivial portion of Euclidean geometry to the non-trivial portion, aka the people who could not cross this bridge were considered unintelligent. What? So like if you didn't understand this proof back in the old days, you were considered unintelligent. Wow. Anyway, okay, let's talk about it. So they gave me number 1, so that is a given. Okay, I'm actually going to go ahead and mark it. All right, PQ, this side. PR, this side. I'm going to switch colors real quick. And then TQ, this side. TR, that side. So they've given me this, okay? That looks like an isosceles triangle, correct? So the reason I know that PQR, which is all of Q, is equal to PRQ is because that's the definition of isosceles. So it's the isosceles triangle theorem. If you put definition of isosceles triangle, that's good too. Okay? So if this is an isosceles triangle, I know their base angles are the same. Okay? All right. Next but not least, it says PQR. So this left angle is equal to the measure of angle 1 plus the measure of angle 3. Okay? Same thing over here. PRQ is the measure of angle 2 plus the measure of angle 4. That's the angle addition postulate. Back to module 1. This total is equal to part plus part. Okay? Now you have to kind of look and see what happened. So here's my blue side, and here's my green side. So notice the blue side went to the left-hand side. The green side went to the right-hand side, okay? Because up here, I knew that this was equal to this, so they just took the blue side, put it in place of it, took the green side, put it on the right, okay? So based off that, that is a substitution property, okay? If I know they're equal to each other, I know what they add up to is also equal. So measure of angle 1 plus measure of angle 3 is then equal to measure of angle 2 plus measure of angle 4. Okay? Now, I know that angle 3 is congruent to angle 4 because here is a smaller isosceles triangle. So that's, again, the isosceles triangle theorem. I know my two base angles are the same. Okay? So now, I'm doing red this time. See angle 3 here and angle 4 here. Well, if they're the same, they're just going to say, well, hey, angle 4 becomes an angle 3. Okay? So if they're the same, I can substitute them in for another. So that'd be the substitution property. Okay? So now they dropped down angle 1. They dropped down angle 3. They dropped down angle 2, and they replaced angle 4 with an angle 3 because they're the same. Okay? Last but not least, they subtracted angle 3 from both sides. Goodbye, angle 3 from both sides. That'll cancel and cancel, leaving you with the measure of 1 equals the measure of 2. So 1 is congruent to 2 based on subtraction property of equality. Okay? Crazy proof, right? And back in the old days, they said you were unintelligent. How dare they? All right. Let me know if you have any questions on that. That is a pretty tricky proof. But we're going to move on. All right, last one, and then you're going to do a little check your understanding. So write the converse of the isosceles triangle theorem and determine whether it will always be true. If yes, explain. If no, give me a counterexample. So remember converse, we did an if-then statement in number 2, and we're just going to flip it. Okay, so let's go back to my if-then statement in number 2. Too far. All right, here is my if-then statement. I'm going to copy and paste it to help us out. So, if a triangle is isosceles, then the base angles are congruent. Okay, so a converse of that is to flip it. So I'm going to say if the base angles are congruent, I'm going to abbreviate that. If the base angles are congruent, then, that's a comma, then the triangle is isosceles. Okay? So again, a converse is just saying it backwards. Okay? So first we said if a triangle is isosceles, then the base angles are congruent. The converse of that is if the base angles are congruent, then the triangle is isosceles, and yes, that is always true. Okay? So the converse is always true. All right. Okay, guys, you're going to try 9, 10, and 11. Press pause, and then I will go over the answers. So see if you can try 9, 10, and 11. Number 9. So Carly said, if an isosceles triangle is obtuse, then the obtuse angle has to be the vertex. Is she correct? Yes, she is correct. So we know triangles have to be 180 degrees, okay? So if a triangle is obtuse, that means one angle has to be more than 90, okay? So for example, 100. If you have 100, you can't have another obtuse angle in a triangle because 100 and 100 is 200, and we've already taken all of our points away for a triangle, okay? So you can't have two obtuse angles in a triangle. It's physically impossible. Look, I tried to make an obtuse angle here and an obtuse angle here, and I did not get a triangle, okay? So if you have an obtuse angle, it's got to be the vertex, okay? Because I cannot have two large triangles. All right, number 10, an isosceles triangle is a triangle with at least two sides congruent. Using this definition, what other type of triangle could be described as isosceles? So keyword is at least two congruent sides. What if it has three congruent sides? Well, hopefully you remembered three congruent sides is called equilateral. So an equilateral triangle is technically an isosceles triangle as well, because an equilateral side or triangle has three equal sides, and isosceles only has to have at least two. Okay? So an isosceles triangle is not an equilateral triangle, but an equilateral triangle is an isosceles triangle. Because to be isosceles, you just need two the same. All right. Last but not least. You have a triangle ABC. I hope you drew a picture because we have to draw a picture. Okay? So I drew a triangle A, B, and C, and it said my base angles are A and C because it said A was congruent to C. Then it gave you sides. So I hope you labeled your picture, and I hope you wrote this information on the outside of your triangle because it is sides. Okay? Hopefully you knew that AB was congruent to BC because in an isosceles triangle, if your base angles are the same, then these are going to be the sides that are the same as well. Okay? So this is what your picture should have looked like to help us out. So then I wanted me to determine all of the lengths of the sides. Now to start off with, I don't need all of them. I only need the ones that are congruent. So since these are my congruent sides, I'm going to set them equal to each other. Okay? This base angle is not important right now. Okay? It's only important at the end. So after you say 4x plus 25 equals 2x plus 45, when you solve this equation, variables on both sides, you get x is 10. Okay? So if I want to find the lengths of the sides, I then have to substitute in, okay? So here's where my base angle, or my base side comes in handy. So I had to substitute 10 into all three of those, and remember substitution is parentheses, so I got 65 and 65 for these two sides, which is awesome because they're congruent, and then my base side is going to be 15, okay? So when they give you sides, this is not like angles, and I would say this plus the bottom equals 180. So 180 is only the inside of the triangle, not the sides. If it is sides, they are always going to be equal, and you just have to figure out which two sides are equal. Okay? All right, you did it! Thanks for watching this video on isosceles triangles. If you have any questions, please let me know. But remember, isosceles triangles, two sides are the same, base angles are the same, vertex at the top, draw a picture to help you out. Now you can practice. Thanks for watching.